So this is a good example of not wanting to lock the rotation, of not wanting to do calculation AOPS. And so when you look at it, you say, well, wait a minute, this looks kind of familiar, right? So I have 2 plus 4 plus 6 plus 8 plus 10, but I can rearrange the top one into just reverse the order, 2 plus 4 plus 6 plus 8 plus 10. So it's really just the same number. Don't even have to calculate it. This something divided by itself is 1. So this is a case of you're not really sure. So if you write it out, you say, well, I have 205 times 205 divided by 205. And you say, well, I think I can just cancel it out and get 205. But maybe you're not sure. And say, take some really easy numbers and just say, well, if I had 2 times 2 divided by 2, is it just 2? And then I can multiply it out and say, well, 2 times 2 over 2 equals 4 over 2. Yeah, it ends up just being 2. So I say, yeah, I think it's just going to be 205. In other words, if I have something multiplied by itself, divided by itself, and you can write it out this way as well, and say, well, is this equal to that? And you say, well, this is just going to be 1, and it just leaves me with that 205. And so as you look at this one, you think, well, I wonder if I can make this simpler. Oh, I don't want to do that. Do I want to do this? So we say we have 64,000 over 800. And you see those zeros. You say, well, is this really 640 times 100 over 8 times 100? You say, yeah, I think it is. So can I cancel these out? Well, so what are you really doing there? You're saying, well, this is 640 over 8 times 100 over 100, but that's just equal to 1, so it's 640 divided by 8 times 1. So it's just 640 divided by 8, which equals, let's see, so this would be, another way to think of it is, this is 64 times 10 over 8. So this equals 64 divided by 8. Well, 8 times 8 is 64 times 10 equals 8 times 10 equals 80. And there we go. So it equals 80. So here's another problem where you're like, oh my gosh, this looks terrible. But then you look at it and you say, well, maybe, let's see how many digits this is. So we have 3 groups of 3. This is 11 digits. And this is 12 digits. Okay, so 12 digits. And this is 11. And you say, oh, well, let's see. So this has 3, 6, 9, 10, 11 sevens, and this has 11 sevens. Say, oh, I see, this is just times 10. Okay, so you say 7, 7, 7, 7, 7, 7, 7, 7. Oh, I can't do it that way, can I? I have to say 77 times 7, 7, 7, 7, 7, 7, 6, 7, 7, 7 times 10 would equal this. So going the other way, this divided by that would be 10. So you say, oh, this is 10. Okay, so it's very handy to, again, take a look. So remember, in AOPS, you're doing some big calculation, probably there's something you've missed, which is that 1 is just 10 times the other. So there's a couple ways to think of this. So you could think about, well, if I have, well, I don't want to have that, right? I want to have, if I have 28 pizzas and they're divided into sevenths, how many pieces do I get? Well, let's see. So, well, sevenths are kind of weird things, right? So if I do that, so each pizza has 7, so I have 7 plus 7. So I have 7 28 times. Okay, so you could think of it that way. But the other way that they would like you to think of it is, and so you can kind of repeat after me, division equals multiplication by the reciprocal. Okay, and how do we do that? Well, it'd be, so we could divide that into two parts. So 7 times 20 plus 7 times 8, so 140 and 56, 196. Another way to do that would be to think of 28 equals 30 minus 2. So say, okay, 30 minus 2, so 7 times 30 minus 2 would be 7 times 30 minus 7 times 2. So some people might find that easier way to do it. 210 minus 14, which would be 210 minus 10 minus 4, which would be 200 minus 4, 196. And you could do it that way. So here's one where the language is a confusion part. The quotient. So quotient is what's the result when I do a division. And so we want to do addition to a division problem. Okay, so we're going to say this is 78 divided by 1/2 plus 10. So we want to do that. Okay, and so then one thing you can do is just say, well, if I have a bunch of pizzas, I have 78 pizzas, so 1, 2, 78, and I divide them into half, then I'm going to have for each pizza 2 halves altogether. So I'm going to have 2 times, so 78 times 2 plus 10. The way they would like you to do it, okay, is 78 divided by 1/2. So multiplication, division equals multiplication times the reciprocal, 2 over 1. So let's see, so we get 140 plus 16, we get 156, and then we want to add 10 to that, so we get 166. So here's an example of something where when you look at you think, well, I should be able to do this, right? Maybe it's just a 16th or something. I keep dividing. But then you kind of go back and say, well, what if I had a half and I wanted to divide those into halves? Oh, well, if I have a half and I want to have 1/2 portions from it, it's 1, right? In other words, if we start here and we say a half divided by a half, and if you're not sure, the other thing you can say is, well, oh, I'm just not sure, so I'm going to switch to that idea of 1/2 divided by a half is 1/2 times the reciprocal. Oh, it's 2 over 2 equals 1. So this first part equals 1. So what's 1 divided by 1/2? And I say, well, it's just easier to multiply. So I'm going to say that's 1 times 2 over 1 equals 2. Okay, so this much has gotten me 2. So seems to be working. So now we'll say 2 divided by 1/2 equals 2 times 2 over 1 equals 4. And it's not what we expected when we started. Okay, so as you look at this one, you can say, well, I see 31, 35, 39, 43, but I don't see 27. What's going to happen when I do that? Well, who knows? But you say, well, what if I had something simpler? What if I had 2 times 4 times 6 divided by 4 times 6? And can I just end up with 2? Can I cross out these 2? And you say, well, I can just multiply it out and see what happens. And it would be 48 divided by 24. Yeah, it would just be 2. Okay, so if that's true, then let's line these up so we can see the same thing. 27 times 31 times 35 times 39 times 43 divided by, and we'll line them up again. So we have 31. Okay, this is just commutative property. We can change the order. 35, 39, 43. And we say, oh, okay. So there's 1, 1, 1, 1. So we just have 27. So it's just 27. So here's another one where you're just not sure if this really works. So you just do it for an easier set up. So you say, well, what if I had 30 times 20 divided by 3 times 2? So let's see, that would be 30 times 20 is 6 and 2 zeros. 600 divided by 6 equals 100. It just equals 10 times 10. Okay, so it looks like it does indeed work to just split it apart into this. So if that's true, then with our bigger problem here, we can try the same thing. We can say, let's do 50 divided by 5 times 60 divided by 6 times 70 divided by 7 times 80 divided by 8. So we get 10 times 10 times 10 times 10. So it's just going to be 1 with 4 zeros. It's going to be 10,000. So you see, again, we're not calculating anything. Didn't need to do any calculation. Okay, so you look at this one and you say, well, let's see, can I divide things separately? And let's just do an easy one and see if that works, right? So what if I had 22 plus 2 divided by 2? Does that equal 22 divided by 2 plus 2 divided by 2? Does it equal 11 plus 1, 12? Well, let's see, it does, right? So we look at it and say, yeah, this would just be 24 divided by 2 equals 12. So, okay, let's do this in 2 parts then. So we're going to take the 11 sevens here divided by 7. And you say, okay, well, what happens if I have 3 sevens divided by 7? Let's see, that's 3 ones. So if I have 11 sevens divided by 7, is that just going to be 11 ones? And you think, yeah, I think it is, right? 1, 1, 1, 1, 1, 1, 1, 1, 1. Okay, so we look like we're good with that. What about 77,077? So for that one, I think we're we can do it in a split as well, right? So 77,000 divided by 7 would be 11,000. And 77 divided by 7 would be 11. So we have to add 11,000. We have to add 7. And so when we do that, we get, I guess, 11 million. Is it? No, 11 billion, 111 million, 122,000. And oh, sorry, it's not plus 7, it's plus 11, 122. There we go. Okay, so as you look at this one, you see a pattern where 12 is dividing something that's twice as big, 24. 22 is dividing 44. And you look at the pattern and you say, well, let's just do a couple of them and see what happens, right? So what if we had 44 plus 24, 22 plus 12? Let's see what happens. So we get 68 divided by 34 equals 2. And so you say, oh, and I'm going to keep adding something that's twice as big. So I think that it's just going to be 2. I just go out on a limb and decide that, right? And you can, another thing you could do is say, I'm going to make a simpler problem, but a little bit longer and see if it works out, right? So what if I had, well, not that. What if I had 20 plus 18 plus 16 plus 14 plus 12 plus 10, and I divided that by 10 plus 9 plus 8 plus 7 plus 6 plus 5. So that's one I can do, right? So I look at this, let's see. So I can put together 18 and 12 is 30, and this is 30, and this is 30. So I get through 3 30s is 90, and let's see what I get here. So there's 15, and 15, and 15 is 45. So yeah, so now I say I'm pretty confident, without doing the calculation, that this equals 2. And indeed, it does, right? It equals 2.